Hello, welcome you again. I'm Sabir Ahmed. This is the lecture 3, and in this lecture we will learn about Matlab plotting. That means how we can plot, how we can make graph using Matlab codes. It's very essential, especially for sciences, especially in mathematics, physics, geophysics, seismologists who do always analyze, because we want our data to be represented by graph, right? Okay, so in this lecture I will show you very basic MATLAB plotting. That means in this lecture you will learn in both normal and logarithmic scale plotting, subplotting, how we can plot multiple plots, and how you can take input from user and show the data. Okay, all those things we will learn from MathWorks website, and it is a very huge uh, and this website for MATLAB documentation. Okay, so from there at first we will go over there, then we will switch to MATLAB programming. Okay, let's go to the website then. uh, this is the math works, and I have told about this in earlier lecture, in the earlier lecture we have learned about language and fundamentals, syntax, operators, data types, array index and manipulation, something like that. So today we are interested about graphics. That means how we can plot 2D and 3-dimensional plot, and formatting and annotation images. Basically we will concentrate on this 2D and 3D plots. Later we will see step by step and gradually. Okay, so let's go there. 2D and 3D plots. We are mostly interested in line plots, which will include linear plot, log-log, semi-log plot. Okay, and other we are also interested in contour plots, how we can plot a contour in 2D and 3-dimensional view. We're also interested in vector fields, comet, compass, feather, quiver, stem plots. We're also interested in gridded surface and volume data and ungridded polygon data. So from here we will mostly emphasize on line plots, contour plots, vector fields, and surface and volume plots. Okay, so let's get started from line plots. Line plot is nothing but consists of several MATLAB functions. The main and the basic and very crucial function for graphics for plotting is the plot function. It's a two-dimensional line data. For example, if we have two-dimensional data, for example x and y, then we can easily use this plot. Okay, so let's get details from here. Okay, so x1 y1 up to this. So if you go to the file, for example we have data x from minus pi with interval 2 pi with interval 2 pi minus pi to pi with interval 0.1. then we have y equal to sine x. Then how we can plot x versus y? It's very easy, and we can use a plot, simple plot x y. Okay, you understand that? Okay, I'm going to right now easily. Okay, we can also plot multiple plots at the same time. For example here, uh, plot sine x, not here, not here. We can also multiple plot with using some other symbols or something like that, and I'm gonna teach you about that in MATLAB. Okay, so this is the very basic plot function in MATLAB. X1 y1 up to xn1. And what does it mean? That does mean that we can plot multiple plots in same plotting system. That means x1 y1, x2 y2 up to xn yn. So we can plot up to the nth plot. So we're gonna teach you about that. So okay, we do have also um, log scale plot. Log scale in x-axis it will be log plot, in y-axis it will be log. Okay, in semi-log x, that means semi-log x, that means in x-axis it is a logarithmic scale. In if you want to plot semi-log y, then it will plot it will make a scale. It make a scale along the y-axis in logarithmic scale. Okay, and the function is error bar. So let's go to the MATLAB to try plot plot 3, 3D plot, 3D line plot, log, semi-log x, and semi-log o. So 3 and 4, 5 programs. Okay, go through this. Okay, for example, we have data. For example, x equal to so let's get x equal to 1 to 10 with interval 0.1 with interval 0.1 to 10. Okay, so we do not want to execute this, so we have to put semicolon here. Okay, let's make another plot. Y is equal to sine, there is a sine function, sine x. Okay, so semicolon here, and we, oh, sorry, we have to put x because we do not have any variable x. Yes, so copy the x. Okay, yeah, so plot this, plot x comma y, so we can easily plot this. Yeah, we do have plot of sine x. Okay, so if we do have another function, for example g equal to cos function x, then we'll get, oh, we executed this, so plot x comma g, so we'll get the cos function. Okay, but if you want to plot the both functions together, then how you can do that? So plot x comma y comma x comma g, sorry, x comma g. Okay, then we'll get two plot here. Yeah, this is a two plot, but we do not know which one is which color does indicate to which one. Okay, so but we learn details all about this, how to make grid, how to make a legend, how to make color over here, and how to make a legend of this later. Very soon we will understand all about that. But I'm going through some basic functions of plotting graphics here in Matlab. Okay, so the CLC is nothing but to clear all the screen things here. Okay, so if we CLC, then it will be gone. Okay, so we are interested in semi-log. So for example, we have a data x equal to 1 to 10 up to 0.1 with interval 0.1 10. Okay, so we do have data y is equal to exp, exponential function. That means e to the power x, e to the power x. And if we put another variable, for example x, then we can plot it in log paper as a log 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 log. Okay, x comma y. Yes, so we'll get a plot here in log function. So if you want a grid, because we do not generally we do it in log paper, the logarithmic scale. So if you want to put grid or want to add grid, then you have to write in the code grid on. So grid on. If we on the grid function, then you can see the grid function here. Okay, so we can also plot this in semi-logarithmic scale. For example, semi log x comma y. So what we will see, we'll see here in semi-log x, in x-axis it will be semi-logarithmic scale, but in y-axis it is a linear scale. Okay, so if we want to put grid on, what you can see, yeah, in x-axis it is a logarithmic scale, and y-axis it is a linear scale. Okay, yeah, so if we do not want to see the grid, then grid off, so there is no grid here. Okay, so this is a grid off, there is no grid off. If you want grid on, then it will be grid on here. Okay, so let's say semi log y x comma y, then we can see here the in y logarithmic scale, and x would be the linear scale, and it would be the logarithmic scale. So if you want grid. Here the grid 1. So there's a grid on. So this is the linear scale x. So you see the same interval, but in y-axis it is not the same interval. It's a logarithmic scale. Okay. Yeah. So this is the way how we can do in plot function, logarithmic scale function, log scale, semi-log x, and semi-log y. We can do that easily. Okay, so let's get back to the Matlab function on mathworks.com. Okay, so these are the functions we have learned. These are the very basic functions here. Plot for 2D line plot, and plot 3 is a 2D 3D line plot, and I'm going to show you other functions as well in 3D line plot. Okay, so sometimes I do have very slow internet connections, that's why it doesn't work properly. Okay. What is that? What happened? I've got some error, I don't know. Doesn't work. Yeah, it does work. Okay, let's see something here, marker. But travel. It does work here, but I don't know why it doesn't control callback. I think my internet is not working. Okay, I'm coming back here and after fixing that. Okay. Okay, welcome you back. Yep, so we are supposed to go to or discuss about the plot 3. Okay, plot 3. Go to the plot 3. So what is plot 3 is about? It doesn't even, it's nothing but to plot a 3D line. So we can do this. So x1, so we need x1, y1, and z1 parameters. So we need 3 parameters to plot this. Okay, so let's go to the so let's see uh, plot 3. So we have x, so if we need y and we need g. Okay, so we do have y. Okay, so if you want to create a j, that equal to, for example, sine x plus sine x plus us cos x, then we have x, y, and z. Then if you want to plot, we already plot 3 x comma y comma z, then we will see a plot in 3D plot. Yeah, so if you want to put grid on, we already grid on, oh sorry, grid space 1, grid space on, so on here, sorry, you see here, or the 3D line here. These are 3D. How the data of three functions x, y, and z varies with spatial domain. So we can plot this. This is the x, y, and this is z. Okay, so this is the plot 3, nothing else. How we can plot a 3D line, plot a line in 3D formation. So we can do that. So these are the basic things of Matlab, how to plot. So I'm going to take you to more detailed plotting system here in Matlab, to the contour plot. Contour plot is nothing, and this is a contour. We know the contour. Contour is the line of same values. That means the isoline values, and we will talk and we will teach you more about this in later section. Okay. So right at this moment, I am interested to teach you about surface volumes. Later we will see later this. Okay, let's get started from here. Vector fields. So what is vector fields? Vector fields nothing to plot vector data. For example, if you want to plot velocity fields or directional fields, something like that, because vector has magnitude and direction. So if you want to plot a velocity of something, then we can use these functions: vector fields, compass, feather, quiver. Okay, quiver is very important. Quiver or velocity plot, this is called the velocity plots, and plot velocity vectors. Feather is nothing, same thing as quiver, but some differences. Uh, we need some UV data. What is UV? Displays the vector specified by U and V, where U contains X components as related to coordinates, and B contains the y components related to y coordinates. So if you see the example here, theta as example here, 90 to up to this is the theta value, right? Okay, and we have r here, to one something, whatever it is, this is the r. Okay, so and we have got, we're getting the uv from the polar chart theta r. So polar chart, so from the, we converting to linear polar region to linear region, theta and r will be converted to linear feature u and b. So in feeder function you will get the in linear format. Okay, so what is quiver? Quiver is much more interesting. It plots 3D velocity plot function. So we need x, y, u, v data for plotting a quiver or velocity plot. So what is x? X is x-axis data. That means x and y spatial domain data. What is uv? Uv is the velocity data. Um, Okay, so the first vector defined is components u1 and v1 displayed, is displayed at the point x on or y on that. So let's see that an example. Okay, so if you want, if you plot the gradient field of the function, for example, g equal to x e to the power minus x square minus y square, then gradient field, right? So that means we have to find out that dx and dy. Dx is the gradient, that means the uh, distance between two grid points, right? In x-axis, and dy is the distance between the 2 points, between 2 points in y-axis. So we want that gradient field, so we need the gradient dx and dy, something like that. The gradient, that means how in x-axis varies with distance, and how y-axis, how the distance along the y-axis varies with y distance. It's called gradient. So you I'm sure you all have heard about gradient, so we can do that easily. For example, we know the mesh grid, so let make a mesh grid point of this here. Okay, minus 2, in both x and y axis should be the same, so minus 2 to 2 here, minus 2 to 2 with interval 0.2, get the 2 to 2. Okay, so let's make what is the function g, and g depends upon the x and y, depends upon the x and y. Okay, so this is the x into point. Why we have x dot? Because x must be multiplied by element multiplication, right? Okay, exponent x dot power 2 minus x dot power 2. Okay, so we can find out, we have a gradient function. How we can find the gradient function of this gradient with two elements, because we have grid with interval 0.2, so we can find out in x and y, we can find out the gradient of z in x-axis with distance is 0.2, and y-axis with distance 0.2. So we can get a counterpoint x, y, z. So we have got x, y, and z. So for using these two equations, you can find out the contour here. Okay, and hold on we used because we want to put contour at the same time the velocity plot together. That's why we want this function to be holded up to we use the quiver function. Then we will uh, uh, hold this function off later. Okay, so what is quiver? So we have x and y, and we have dx and dy, the gradient of z function. So dx and dy. Okay, let's go to the Matlab and exercise this uh, to understand the quiver and to understand the quantum value of this. Okay, so go to the, so TLC clear. Okay, if I do, so I'm gonna make it, so let's make it x equal to 1. So for example, let's make our data ourselves, uh, 1 with interval 0.2, for example. Okay, and with interval up to 10. So what is that? That equal to x dot into exp minus x dot power, so this increase power, okay. um so minus y dot power 2, okay, and we'll get a function here. I hope we didn't find any problem with that. What I made, uh, minus and y dot 2. Oh, we didn't find the mesh grid. I'm sorry for that. We find the mesh grid. Um, x comma y, because at first we need a special domain function x and y, and in this function the j will how g, that means at first we have to make a domain. So this is the domain with in x-axis minus 2 up to the 2, and in y-axis 2 minus 2. So at first we have to make a grid, right? At first we make a domain of this. So how g, that means how this equation varies in this domain. So you want to find this, how the gradient of this equation varies with this, okay. So definitely we must have to make a grid or domain. So image grid, grid image grid. So 1 with 0.2 interval up to, for example, to 20, okay. So this, and we need to calculate g. So x dot multiplication with exponential minus x squared, that means minus x dot 2 power 2, okay, minus y dot power 2. So you have got, hopefully you didn't make any mistake. Yeah, you didn't make any mistake. If you want to find the contour, um, so let's make a function to find out the gradient. So for example, dx comma dy, so we need a comma or something, yum. So dx dy is equal to gradient g, how this gradient will be varied in x-axis with 2 interval, the same thing with 2 interval in y-axis. So we'll get gradient here, yeah. So we can find out the contours and contour, that means we'll get a isoline of this of g. So x comma y comma g, but let's see, yeah, only the g here. We've got the g, we've got the contour here. So if we hold on, it will be hold this on, then we want to plot this function, that means the quiver function, right? Quiver, quiver function. So quiver, so we need x, we need y, and we need dx, and we need dy, okay. So this will be here, and hopefully let's see how this varies here. If we want to see this one and how this can vary, you see, so this varies along this. So it's a vector, and we define. So from this, what is the significance of this? Okay, I'm gonna make you understand. What does this mean? This means the function we made, x equal to with exponential x square minus what y square, right? With our data 1.2 up to the 20, with our data marches towards 0. That means this equation will be vanishing soon if we put more data, something like that, because it will going to 0 function. It will going to the origin of a coordinate. Okay, so hold off, and if you want to make a grid on, here the grid on, then it can see, yeah. So this is the things we want to see. So if you do not want to get, then get off. Okay, so this is the function how we can do quiver, and so from this we have learned gradient function, mesh gradient, contour. So contour is nothing. um, Contour is this is the same isoline. That means this line represents the same values of g. That means of j here. So this line represents the same value of g. Okay, and these are the velocity indicators, so direction. So how these lines are moving or converging to, how this where this lines are converging to. So this indicates this. So direction of lines, that means the future of these lines. So if you're from dynamical system mathematics student, then you can understand how this equation and how this thing uh, uh, can be behaved or will behave with time or something like that. Okay, so this is the very fundamental things of quiver function. Okay, so if you want to, what is this color map? So I'm gonna make you understand more. um, I'm gonna teach you about the color map later. So for example, if you want to add the color map, then what makes it change? Nothing. Okay, I'm gonna teach you later about this. Okay, so let's go back to our function. So hmm, so we have understood what is the feeder, what is quiver. So quiver t is nothing, is a 3D quiver velocity plot. So let's see if you want to, what is the quiver t velocity. So you need x, y, z, and u, v, w. These are another line. You know, these represent the one two-dimensional contour. So definitely we must have u, v, w for this, right? For representing the 3D. This represents 2D, so we need another UVW for representing it in 3D. So what is UVW? Well, vectors and points where UV and Z will Z all of real complex or something like that. This is a very, if you explore this more authentically and if you are more interested about that, then I think you should go through this. Okay, so let's go back to our basic plot functions. Okay, sometimes my internet makes it very impossible. I don't know why. Come on. Yeah. So 2D and 3D plots. So we have seen about the line plots, we have seen the contour plots, we have seen vector plots, and we are now interested to see about surface volumes and polygon functions. We will not see all of these functions because it will take time, and I'm gonna show you very basic functions of this. Okay. So we're interested here representing graded data as surface and mesh plots. SARP. So what is 3D shaded SARP is very important thing. 3D shaded surface plot, and how we can represent um, the 3D plot with surface. That means we need a surface x and y dimension, not a line, because for line we have a plot 3 line. Okay, for surface we need a surface. How an equation behaves with surface in a domain. For example, here we have x, y, and here we have also x, y, and here we have also g, right? So we have three-dimensional data. So let's see how this equation behave in, we have seen this equation behaves in two-dimensional line, right? So if you want to see how this equation behaves in three-dimensional, then how we can do that, it's very easy. So let's get to the surface function in three-dimensional 3D shaded surface plot. Okay, so we require that we require first xyz data, right? So xyz data, so we have uh, some information here, so do not worry about that, because we have already three-dimensional data x, y, and z. Okay, so su r f are in x comma y, and you want our equation to be represented in three-dimensional, so and three-dimensional, and it would be in surface. So how this, yeah, so we have seen in two-dimensional that in this part our equations were only here, right? Yeah, so we see that how our equation um, we have in three-dimensional. Yeah, so if we have another hmm, data, for example, hmm, for example, uh, we want only um, g equal to exp sorry xpx, and we want to add some another data sine x. Okay, so let's plot this. If we here, yeah, look at this. For this is the one equation. For this equation, we have already seen how this equation varies in three-dimensional superficial data in three dimension. And this is another equation, exponential of x plus sine x. So how this equation varies in three-dimensional. So we can represent this easily with surface function, right? Okay, so this is nothing. From the sphere n, we can also find out the xy something there. There are lots of things you can do with Matlab plotting function or graphical functions. There's another function, mesh plot. We can also plot a mesh. For this also we also need this xy data. The same as R. Okay, these are the same things. It's called a square root, something like that. We do have xy data, right? And we do have R, something like this. For example, say this, and we find the G data, and in this spatial domain how G varies, so we can find out the mesh. Or we can even use xyz, okay, xyz. So gradient, we find out the gradient of J, how gradient varies this, so we can also find out this. It's very easy. So these are the very basic functions of very basic graphical uh, things we need to represent the equations. We need to represent our data and functions in two-dimensional, three-dimensional, back in vector representational, line or semi-logarithmic plots. Okay, so another things we must to know all about that, because we must have to know what is x-axis, what is y-axis, what is z-axis. Nothing, but we have some other functions for that. For x-axis leveling, for y-axis leveling, something like that. Okay, let's go back to graphics and um, formatting and annotation. That means how we can represent our title and levels and coordinate system, axis limit, something like that. Titles and levels. Nothing. This is the title. Title is a function at the current title, right? X level, level x-axis, level, y-axis, z level, z-axis. Okay. So in this function, let's put all of this. We want to put a title. We want to put a x-axis. We want to put a y-axis. Then we finally want to put a z-axis. So how we can do that? But it's very easy. Title, title. We have to put all our thing. Sorry, inverted comma. For example, um, plot of, for example, say this is for plot of, for example, xpx x plus sin x. So okay, this is already added, the plot of xpx sin x. So if you want to x level, x l-a-b-e-l, x level, right? Here the x level, y level, and g level. So whichever you want, bring to x level is same, inverted comma. For example, x level is value of x, value of x. Okay, wow, y, y. These are not capital letters. Okay, these small letters. Y level, y level. Um, value of y. G L A B L level. Value of a. Okay, so these are things. So we can do that. So let's see what happened over there. This happened. Yeah, so x value of x, so this is the x values, this is the y values, and this is the z values, and this is the title. Okay, so if you want grid on, so grid on. So if you want a lesion, but that means no lesion. If you want to put our uh, color bar, so what does this mean? What does red color means? What does black or blue color mean? So there's nothing. Plot your color bar. Color bar is a function to represent the color of z value. Okay, color bar. Oh, sorry, I made it. Color, COL or BR. So I didn't put O here. Color bar. Okay, so this is the color bar. Okay, so and this represents the G value. So you know G from 0 to 10 to the power 5 into 10 to the power 0, 10 to the power 8 to 5 into 10 to the power 8. So this black represents almost 0 value. So you know this represents almost 0. So black it represents almost 5 or something per point, right? So it represents the G value. Okay, so these are color bar properties. So if you do not want grid, then we have to put grid off. What is that? Undefined function, grid point program this. I don't know what is that. Okay, so we can do that. Oh, I didn't mistake. Grid off. Yeah, so there is no grid here. You can identify how this equation varies with spatial domain. So these are very basic functions for Matlab annotation. Contour plot elevation level, sea level means contour plot, data formatted tick level, deity, date. So if you want a date formation, something like this. Lesion, if you want to lesion, okay. So we have already seen the color bar. So lesion, what is lesion? For lesion, we have to put lesion. If you do have more deep data than we could have. Okay, let's see. Let's clear this. X, for example, 1 with interval 2 up to 20. Okay, so y1 is equal to sine up to x. Okay, y2, sorry, what is equal to sine cos x. Okay, and if you want to plot with plotting function x comma y1 comma x comma y2, then you see, right? So we can also put a title, sorry, put a grid on here, grid one, so grid, it's already grid on. I do not know which one is more clumsy. So grid off, yeah, grid off. So there is no grid off. Okay. So if you want to know which color represents the which equation, we can add a legend N E G E N G E N D legend. So we have two two equations. So first equation is the sin x. So the sin x, comma. Second one is cos x. Cos x. Okay. So let's go to here, and here the blue one represents the sin x, and the green one represents the cos x. Okay, so if we want this line to be represented by not solid by a dash dash, then what we can do this? Or if you want to change this color, then what we can do this? Yeah, there are several options of that. But that's why I made I've opened some uh, color marker or do something like that. So let's go over there and see. So we in Matlab there are different line style. Dash, that means generally it is represented by dash, the dash dash, colon, this is not colon, this is the dot, and the dash dot, and none. Okay, this is line style. So this is a solid line, These are dash lines, the dotted lines, that means dot dot, and the dash dot line, and none, that means the no line. How we can do this? And we do have other lines. If you want this line to be up to this point or something like this point, okay, so we can also do that. Marker, character marker also here. Specifier, so if you want character marker plus or something, even we do have color marker. For red it is marked by the R, blue by B, magenta by M, and red by R, and this one cyan with C, black K, white W, and yellow Y, and so on. And so how we can change this easily? Okay, we can change this easily. For example, if you want, and we want this line to be represented by R, and this would be uh, dash dash. This would be dash dash, for example. Okay, dash dash, and we want this line be default. Okay, so what happened? Oh, sorry, I did a mistake, and this should be represented same here. Yep, so this just means this line is red and this be represented by dash dash. So this will be, oh, another problem, I don't know why. What happened? Okay, x2 y2 x1 y1 r dash dash error balance or something like that. Oh, okay, so this line, okay, I think we have to define b dash. Yeah, so we also have to define all other things as well. Yeah, I might be wrong, I'm not sure about that. So we have represented this color with the red, and this color is the blue solid line, and the red dash dash line. So we can do that easily. We can add a legend here, legend, for example. So first one is sin x, second one is dash dash cos x. Here Matlab, yeah. So we can also put x-axis level, y-axis level, title. We can put also grid here, and if it is a logarithmic scale, then we could have plot log log, semi log. In case of semi log, we could have plot it in semi log paper, something like that. So we can easily do that. Okay, so these are the Matlab basic plot functions that we are interested uh, in basically about that. So this is very important at this moment. So we do have another functions coordinate system which have axis limit, aspect ratio, decorations, multiple plots. We can do that easily. X limit, set or query x limits, or set or query along y limits, or set or query and z limits, box or grid line. So we know use all about this. We can also return the current graph when adding new graphs. So hold on. Okay, we have another function subplot, which is very important thing, because in one figure we can represent, for example, in one graph we plotted the two functions, right? This one, but this can be represented separately. For example, two figures. For example, in this window we can in separate we can represent these two functions to be represented in two separate graph in same window. Okay, how we can do that? We can do that using this subplot. Okay, let's see about that. Okay, for example, so we want those two functions to be represented by two different graphs but with same figure. Okay, so we have a figure 1. So fi0 figure. So with this figure, this is the figure. Okay, so in this figure we want one function represent in this plot and another function will be represented by on this plot. Okay, so we have to use subplot. So we want, for example, what is that? Okay, so we want one row, that means one row and two column, and two functions represented by the two plot with uh, one figure, right? So two figure, that means one column, two column, but one row, right? Okay, so one row, two figures. So we are now working on row 1 column 1, that means the first figure. Okay, so we have here, so this is the row 1 column 1, and this is row 2 column 2. So the first function will be represented by here, so we are working on this. Okay, so plot, for example, x comma y1. Okay, so if you want to create here, read on here, right? So the first function by representing here. Okay, so if you want the second function to be represented by a second column, so we have to add the second column, that means the second one, right? Okay, so uh, the second column has been created here. Okay, so PLT plot x comma y2. So here the grid on. Yeah, so sub functions have many facilities. So if we could have want this to be represented by two rows, that means this one, and there will be figure here, another one by one column. So here will be the two rows, one column. Okay, so this is the very important thing. Okay, so we have understood, we have learned about the whole subplot x is scaling and appearance, how it would be. So it's very easy, so you can go this, that x limit, and we have uh, plot was that. So these are the things, these are Matlab basic functions. So if you want to explore, if you go through this function, you will find out more details all about that. Okay, so I think we are at the end of this graphics or plotting class, and I think you have understood all the things I tried to. And I could have talked to you about data exploration, because we could have huge amount of data and how we could do this, and I'm gonna show you how to export those data into Matlab and how to plot those data later on. Okay, in the next tutorial, next video. Okay, so in the next lecture we'll see some examples. We'll see some mathematical treatment, how we can use Matlab for our physical problems, mathematical problems, or to solve those problems, to solve mathematical, physical, or chemical, or geochemical, geophysical, seismological problems to solve over there. We will see in next lecture 4. Okay, I hope you have understood all the things I tried. Okay, I hope I tried my best to make you understand. If you didn't go through the topic any of the topic of this class, of this lecture, please do not feel uh, hesitate to write me. Okay, so thank you very much for being with us, and hopefully we'll see you next video.